Welcome back on to the following episode where we talk about problem 2 in MathMeowTics. We're going to find the length of a leg. Okay, now that means that if we're talking about the formula a squared plus b squared, the Pythagorean Theorem, equals c squared, that means we're looking for the value of a or b. We're not looking for c. In reality, let's look at this real quick. Let's just, before we get into talking about the problems, let's say that I know what the value of c squared. I can rewrite this equation. And I can say c squared, so I can, let's say we talk about our understanding of literal equations. Literal equations mean we have more than one variable. Let's say I subtract b squared from the left side and I subtract b squared from the right side. So then that would give me, this would become a zero pair. So then I would have a squared is equal to c squared minus b squared. So I could find the value of a squared, or that leg a, by subtracting the other leg from our hypotenuse. And again, I can do the same thing with a. So if I were to do, say I have a squared plus b squared is equal to c squared. If I subtract a squared from both sides of my equation, that's going to end up giving me b squared is equal to c squared minus a squared. So again, I can find the value for b by subtracting the other leg from c squared. So I know that I can find either a or b by subtracting the other leg from our hypotenuse. Okay, I just wanted to do a quick review of that. So, in other words, again, and we said previously in the other video, it really doesn't matter what leg we use, because, I mean, the commutative and associative properties of algebra tell us that if we have a plus b, and that I can rewrite that as b plus a. They're interchangeable. I can move those in any order that I want. So because that's the case, I know that in reality, if I'm adding those two numbers, the two legs together, and always adding the two legs together, the order of that on that side of that equation doesn't matter. So here, it denotes the longest leg here. It denotes the longest leg as being b. And that's okay. I could have labeled it A, but in the terms of this problem, it labeled it B. So I'm going to rewrite my inequality. Let me do a different color. I'm going to do green. All right. So we have A squared plus B squared is equal to C squared. I don't know what value of B is, so that's our question mark. But our A value, it gives us, so A is equal to 5. So then I'm going to put 5 squared. Don't forget to put the square there, because this is essentially saying you have like parentheses, and that number, whatever's inside that parentheses, is squared. So that value of 5 is going to be squared. So this is going to be 5 squared plus b squared is equal to. Now again, it gives us the value of c. So c is going to be 13 squared. Again, make sure that you understand that that's implied that it's in parentheses. That exponent only belongs to that base. Well, 5 squared is going to give us 25. So I'm going to say 25 plus b squared. Don't forget your squared. And then 13 squared is going to be 13 times 13. So that's going to be 169. Now I'm going to subtract 25. Subtract 25. So then that's going to give me b squared is equal to 169 minus 25 will give us 144. Now, again, just like before, I want to get the b by itself, so I need to square root it. So I'm going to square root both sides. So b, because what I do to one side, I have to do the other side. And again, it's a plus and minus situation, but we're only dealing with the positive side because we're dealing with a value here. And we can't have a negative side length. So the square root of 144, let's see. Oh, we got lucky. That is one of our perfect squares. So that answer is going to be the square root of 144 is 12. So our value, the side length of b, is going to be 12. And don't forget our units, 12 centimeters. Not too bad, not too bad. So see, yeah, it's not too bad. Pretty straightforward. All right, now, let's see, identifying right triangles. So that means that we're given different choices. We're given 3 sides. And we need to see if those 3 sides will even up or work out. Now, that means that we're going to square all of these side lengths. So I'm going to take 6 squared plus 24 squared is equal to. Then we have 18 square root of 2, and that's squared. Okay. Now 6 squared is going to give us 36. Let me clarify this further here. Hold on one second. So when we're dealing with triangles and we're dealing with side lengths, A and B is always going to be, the values of A and B should be less. The longest side is going to be our hypotenuse. So I need to see, let's see, 18 square root of 2. That is the longest side. So I wanted to clarify. So 6 and 24, those are going to be our potential legs. 18 square root of 2 is approximately 25.5. So that means that that would have to be the hypotenuse. So we can say 6 squared plus 24 squared, and let's see what that equals. So 6 squared, that's going to give us 30. So we don't know if it's going to equal 18 square root of 2. Let's check. So then we have 36 plus 24 times 24. That's going to give us 576. Ooh, that's a big number. We still don't know if that's going to equal 18 square root of 2. So 36 plus 576. So that's going to be 612 question mark equal to 18 square root of 2. All right, now here's a trick. We have 2 left side inside the radical. So that means that whatever number that was in there that gave us the 18, it was multiplied by 2. So I'm going to take 612. And I'm going to divide it by 2. So that gave me 306. So let's say 3 square root 306 times 2 equal to 18 square root of 2. Maybe. So now let me see. Let's take the square root. So second math, square root of 306. That gives us 17.49. So that's not a, that is not the possible lengths of a right triangle. So that won't work. Now let's try B. So 5 square root of 3, that is 8.6. So that's one of our legs. Our hypotenuse is going to be 10. So we're going to say 5 square root of 3 squared plus 8 squared is equal to 10 squared, the value of 10 squared. And, oh, wait, hold on. I made that mistake. Let me try something real quick. Go back to this real quick. Nope. Let me clarify that. This here value that we didn't even have to do down here. If I took 18 square root of 2 squared, that would have been 648. 612 does not equal to 648, so that's not that tells us our answer right there. All right, so I should have clarified that that should have been squared each time. All right, so 10 squared is 100, 8 squared is 64. Now let's put in our calculator. We're going to have to put 5 square root of 2, square root of 3, sorry. And square that. That's going to give us 75. 75 plus 64 is going to give us 139, which is not equal to 100. So this is also not a side length for a right triangle. Let's move on. Let's try C. So we have 4, let's make sure, see which one's our side length. 6.9, so the first two in our, these two are our side lengths. So we're going to say 4 squared plus 4 square root of 3 squared is equal to 8 squared. Now, again, let's talk about if we don't have a calculator when we take 4 squared and we have to distribute that to both terms. So that would end up being 16 times 3, which gives us 48. All right, because if I distribute the square to the square root of 3, remember that's 4 times the square root of 3. The radical and the square cancel each other out. So then when I take it outside of the parentheses, it's and to the power, that's just going to leave us with 3, and 16 times 3 gives us 48. So just so you know that if you don't have a calculator, you can still solve these. And 4 squared is going to give us 16. 8 squared is 64. So 48 plus 16 gives us 64. 64 is equal to 64. That is a right triangle. That does work for a triangle. Now let's double check the last one just so that we get further practice. It might be a good idea for you at this point to pause the video and see if you can answer D and determine whether or not that is a possible triangle for a right triangle. I'm going to do it here. So I have 8 squared plus, let's see, 12 square root of 2. That is our longest side, so that's going to be our hypotenuse. So we have 8 squared plus 16 squared is equal to, that's going to be 24 times 2. 24 times 2 is going to give us 48. So then 16 squared, that's going to be 16 times 16, 256. Well, right there off the bat, we know that that won't work for a right triangle. So I really honestly don't have to go further. Because if our squared here is going to be bigger than our 12 squared 2, that won't work. Okay? So we are done in solving that problem. Our only answer choice is C. I will see you in the next video where I will talk about the remaining problems. I don't want to take a whole bunch of time here. So I'm going to go ahead and finish up the last problem, and then maybe do some of the example problems on the following video. See you then.